Good morning everyone. In this video we will discuss about what is isomerism and its types. So generally we know iso remains to be same. Iso means same and with different compounds its structures. So therefore the definition for isomerism is stated like this. Compounds having same molecular formula but different structural formula is defined as isomerism. As all we know that isomerism is basically classified into two different types. Number one, it is structural isomerism, and second part, it is being divided into stereo isomerism. So let me tell you what is structural isomerism and its types, and later on I'll tell you about what is stereo isomerism. So structural isomerism is further classified into four major branches. It is chain isomerism, position isomerism, functional isomerism, and the last one is metamerism. These are the four types of isomerism in which the organic compounds can exhibit. And further we have a tautomerism also, and we have a keto-enol isomerism also. So they are also the isomerism type which can be included in particular chapters, but basically these are the common isomerisms are exhibited in organic compounds. And coming back to the second side, we have stereo isomerism. Stereo means nothing but bulk isomerism. Stereo is other words we call it as bulk isomerism, and the atoms in this type of isomerisms are spatially arranged, spatially positioned we can say. So therefore stereo isomerism is classified into two subdivisions. One is geometrical isomerism and another one is optical isomerism. So as the word geometrical isomerism is indicated, we can clearly explain the isomerism. Well, further, geometrical isomerism is classified into two major divisions as cis and trans isomerism. Cis isomerism and trans isomerism. So this is how the flowchart of isomerism has been classified, and let me explain you each and every isomerism with an example now. So before going to the examples, we'll once again remind you the definition of isomerism. Compounds having same molecular formula but different structural formula is called as isomerism. So here we go with the isomerism and its explanations with an examples. So chain isomerism, as the name indicates, chain isomerism, you could have come across many chains in your life, that it might be a straight chain or a branched one. It might be a straight chain or a branched one. Here you can observe in this type of isomerism, of chain isomerism, you can see we have a compounds that, as the definition states, they should have same molecular formula. Both the compounds, both these compounds have the molecular formula C4H10. Look at the structure here. The first structure is linear in nature and the second one is branched. Therefore the first one takes the name N-butane. Having the molecular formula C4H10. The second one with the same molecular formula takes the name isobutane, where this iso represents which group is termed as iso. You can see here the group which is being marked inside the dotted line. The group which has been marked inside the dotted line is nothing but called as iso, and therefore since we have 4 carbon, they have been represented as isobutane. So this is the best example for chain isomerism. When we come back to the second isomerism called as position isomerism, position isomerism is also in the same type. Here the position of the function group should be mentioned here. So where they have been particularly attached, to which carbon they are attached, whether they are attached to the first carbon or second or the third carbon. Here we take a best example of propanol, which bears a molecular formula C3H8O, which takes alcohol as the function group. So C3H8O, it bears a formula, and you look at the structure. The first one, the OH group, the function group of alcohol, is attached in the first carbon. According to the IUPAC norms, we can number the carbon atom on the either side. So as you know all well, the rules of IUPAC, the function group carbon should bear a least number. So therefore I pick up the rule numbering from towards left. It is number 1. Therefore 3 carbon takes the name propane. Number 1 function group position 1, and function group of alcohol should end up with all. Therefore it is propan 1 all. Look at this another structure which bears the same molecular formula C3H8O, 1 2 3 carbon, and the OH group is attached over here in the second carbon over here. So therefore the name of this compound will be propan 2 all. In order to to exhibit the isomerism or to explain the isomerism, what we have to do mainly is we have to generally bring the carbon atom towards any one of the side. I could have shown here over here the earlier structure you see. To get another structure, I have to move either left or right. I have to move either left or right, or I have an option of moving top or bottom. So this is what the isomerism structures can be exhibited for different compounds. There are two rules you can use it up to get different structures. One option you can make use and move either left or right. Another option you can move top or bottom. So here we go, I have done like that. So I have brought CH2 group down, and thus we get the second structure over here for propan to all. Look at the structure here now. The second example for Persian isomerism, I've used an alkene system, hydrocarbon, unsaturated hydrocarbon system. Look at this compound here bearing the formula C4H8. It's purely an alkene.